So JRE, JDK and JVM differences, we'll understand that. Okay, so I already covered this portable language and architecture neutral, because all this why portable, why architecture neutral is because of bytecode. So the bytecode is anywhere, any hardware, software, any architecture, it will work out. So it's a high performance programming language because so it's very close to a native code. Already Java developed some code, that code, and once you bytecode, both are very close, and it will take it fast and execute that very quickly to you. So Java is a distributed programming language. So if you want to develop a distributed applications, there is a Java Beans, okay, Java Beans concept, RMI and Spring Boot, and these latest technologies are used to design the enterprise and distributed applications. And Java is by default multi-threaded applications. Multi-threading concept it supports. So what is meant by multi-threading? So multi-threading is nothing but just each thread has a one separate program. It will be executed concurrently. Suppose one resource, one video, you are using, I am also watching, somebody is watching same video. How is it possible? Because of this threading concept. So each, the resource is same. So the resource occupies some memory, right? The same resource can be utilized by multiple people because of this threading. So each person, it will serve, one thread will create, that thread will serve for. But the memory it uses is same memory. So each thread, it doesn't occupy separate memory again. The resource occupies the memory, but when your multiple people are using the same resource, the threads will create. And that's the multi-threading concept. It's like mostly this, where you will use all web applications and all multimedia applications, this multi-threading concept is applied. So Java is a dynamic programming language because on-demand basis, the classes will be loaded to you. So which class you want, that class will be loaded. So that's the is a dynamic programming language. So already native language code is there, right? So that code and on demand, if you need a one class, so that class code will load. Okay, so that's the all the features of Java. Okay, any questions on the features before moving on to JDK, JRE, JVM? Okay, so no problems. So if you don't have any questions, so please go through this and note down this, the URL. Whoever doesn't know how to use the blog, I see many people struggling to use the blog. So the left hand side, you will find all of them in the label. Okay, so there is a labels. Topic wise, all of them you can find out under labels. So you can see here, core Java introduction. This is the topic we are discussing now. So first you should know how to use the blog. If you don't know how to use it, it's difficult. See, you have a data types, everything is available here. Okay, so that's very important. Using the, so blog is another, so very important. Okay, so let's move on to the next one. The difference between JDK, JRE, and JVM. So what is JDK? So JDK means Java Development Kit, and JRE means Java Runtime Environment, and JVM is a Java Virtual Machine. So JRE is just if you want to run your program, you must have a JRE in your system. If you don't have JRE, your program won't run. So just for running purpose, you will use JRE. So it's a runtime environment. And so if you see that, let me show you that. So this is the JRE. So JRE is a set of libraries, other files, and JVM will be there. It contains JVM plus set of libraries. Library means reusable code, already Java developed code that is there in the rt.jar file, Java archive files. .jar means Java archive files and other files, all the different files they have created, right? Those files you can use for your whatever the class you required, it will be available here in these libraries. So once this is done, okay, so this is the JRE, but nowadays separately there is no JRE. So everything is mixed in the JDK. So JDK means JRE plus development tools, Java development kit we call that. So if you want to develop your code, applications, anything, you should have a JDK in your machine. Otherwise, it's not practical. Okay, and see, when you see this JRE, now Java 11 or Java 9 onwards, mostly, they are not separately showing JRE and JDK, so different folders. But Java 8, you will see JRE separate folder and JDK separate folder if you install Java 8. But after that, so why they have clubbed everything in one? Because this is already part of JDK. Again, no need of showing it separately JRE and JDK. That's why they came to a conclusion. Okay, it's bundled already. JDK means it's bundled. If you have a JDK, so automatically JRE is there. So that's why they are not showing separately after Java 8. So we have a different tools also, interpreter, compiler, archiver, documentation generator. So all these are available in JDK. So based on your application development, you can use different tools. These are development tools. Java C is one development tool, Java. So all these are different tools. Okay, so that's a JDK and JRE. Let's move on to the JVM. So let's understand the JVM. It's a bigger one. That's why I just kept the last one. So JVM architecture. So Java virtual machine is an abstract machine. It's a core. Okay. So in the Java application development, JVM is the core area. So part of everything Java applications is JVM. Okay, so the JVM has a lot of components. First one is a class loader. It's one of the subsystem in the JVM. Then this entire section is the memory areas. Why do you need a memory? To store your data, right? So that data will be stored in different, see, method area, heap area, stack area, PC register, native methods. So how many memories total? Method area, or this is also called class area, heap area, stack area, PC register, native method stack. So these are all the memory areas. What are the different memory areas in JVM? Method area, heap area, stack, PC register, native method. So each memory wise the data will go and store. So now it is loading, right? Your class file will load here. Who is loading your class file? The class loader. So this class file is loaded into JVM by class loader. Once it is loaded, then it will come into these memories. Respective memory areas it will go. So in your class file, you have a data. That data should store somewhere, right? So based on the data you are storing, that will go to this memory or this memory or this memory or this memory or this memory. So that I'll tell you which memory, where it is going once we progress little bit. So we should understand what is method area, heap area, stack, PC register and all this. Basically, remember, I'll give high level. So the static data and static methods will go and store in this method area. Non-static data, non-static variables, non-static methods data will go and store in the heap memory. So this will be only when you create an object for the class, that time only it will store in this heap area. In the stack area, so your local data are currently which frame is executing, that frame data will be stored in the stack area. Once that frame, that method is over execution, then the local variables will be destroyed from the stack memory. That's why local variables are not accessible in another method. Because once this thread 1 is over, that means that method 1 is over, and all this local data is not visible to you. It will be destroyed completely from the stack. So that is the reason one method local data you cannot use in another method. So like this, in number of methods you can execute. So method calling, method local variables data, all will store in the stack area. So the current which thread is executing, that thread will be registered in the PC register memory. Native method stack means any native methods you are using, that will store here in this memory. So that's all about the memory areas. So this is called heap area is called runtime data. This is the static data. So once class is loaded, it will load the in the class area if there is a static variables or static data in the class area. So but only once it will store. But in the heap area, it's not like that. How many times you create object, that many times memory occupies in the heap area. Same variable, same data, it will store in the different memories if you create multiple objects. So that's the heap area, stack and PC register. And another one is execution engine, very crucial. I told you, right, interpreter. So this is the interpreter, just-in-time compiler and all this. So the performance related will be improved here by just-in-time compiler, and main execution is done by, because it will store in the memories, right? The data is your data is coming from class file that will store in the memories. From the memories, the stream byte will be taken by this interpreter and executes it and gives the output to you. So and on the other side is garbage collector. So any unused data is there, the garbage collector keep running and it will clean up. So and it will take any native code is there, native library code is there, that also taken from so these libraries. So this is the overall architecture of so JVM. So this is a very important, if you understand this memory areas, how data is loading, where it will store and how it is executing, is important. Okay. So I want you all go through this and write in your own words about JVM and send it to me. So in my, through my mail ID, do that. And tomorrow we don't have a class. Every Tuesday also we don't have. I'm thinking next time onwards, maybe Saturday I will, Sunday we'll take a class instead of Tuesday. We'll plan that. Okay. So